Hello, I'm Diego Lopez, and well, good morning, good evening, good afternoon, whatever the time of the day, depending on your time zone. The plan is that for this talk is precisely to introduce you to how we are addressing quantum communications and in the environment of what we have called the MadQCI, which is our quantum communication testbed that we are running in Madrid, precisely. First of all, just to introduce the issue is why we are interested on this. Is evident that this is the next step, or one of the next steps in network services, is about quantum computing. The interest in quantum technology in general would require precisely quantum communication. This is something that is important for us to produce new services, leveraging the available infrastructure, and for sure make networks more usable and sustainable, and well, why not again gain some competitive edge for us. And we have been working on this for quite a long time, and this is we will see this precisely in how we arrive to the MadQCI later on. Just as a note, and this is important, why a testbed, and why a testbed with these characteristics is because right now quantum communications are not easy. They are difficult. They have several limitations. They have several interactions with, if you like, with matter itself. That implies that it has problems with the limited reach. Right now, technologies require, well, not necessarily actual point-to-points, but very close to it. Signals have are very weak, and it's difficult to interact with others, other uses of the infrastructure, as they are interpreted as noise. In general, is something that is, as a summary, is quite delicate, and we are seeking precisely for compatibility of the technologies in operations, in applications, and in the infrastructure itself. For the way for this, and as I said before, we have been we started about a long time ago, more than 10 years, 12 to be precise, in which we started a very tight collaboration with the University in Madrid, the UPM, that has been collaborating with us in all this on quantum communication since 2007 or 2008, when we planned for this first demonstration of using QKD. That was the technology that the quantum communication technology that is closer to the closest to the to reality. We made a first demonstration, as I said, in 2009 using commercial infrastructure, and we recently, 3 years ago, we built a first field trial of integration of a particular approach to QKD based on continuous variables, and the integration with this SDM mechanisms again on commercial infrastructure. Today the MadQCI is growing from this initial limited ring, the triangle that you have in the center depicted in red, that to a much wider infrastructure that has a set of characteristics that I believe are very interesting, precisely for experimenting in these directions that they were mentioning before, of making quantum communication feasible and suitable to be used as part of normal network services. The MadQCI is run on production facilities everywhere on the two operators. We will talk about this later on. Nothing has been, nothing in the infrastructure, in the buildings, in the way in which everything is operated has been explicitly designed or thought in terms of quantum communications, and we are following all the normal operational procedures in each of the participating infrastructures. We are making a strong emphasis on integration, so trying to share as much as possible the different physical and logical components. From the beginning, we have decided to define and enforce SLAs as in a real production network. we are trying to integrate mechanisms from, devices and procedures from different manufacturers. It's true that in current situation of the quantum communications, you cannot connect devices from devices from different manufacturers, but we are trying to operate the whole infrastructure in a way that is consistent and multi-vendor. And for sure, we are taking into account users, and we are running several demonstrators already on the infrastructure within a couple or well, more than a couple of research projects that have been funded by the different initiatives of the European Commission, in particular the Quantum Flagship, and some local pilots with specific customers. We refer, and I'm using the title, and this is something that some of you were intrigued and asked me about this idea of the multiverse, but it's precisely this. We try to make it as diverse and rich as the real environment will be in the future when quantum communications become part of the common network services. We are sharing as I said before, the infrastructures are being shared in among the different communication mechanisms, which is important because we try to maximize the usage of the infrastructure on the one hand. We are combining different technologies for quantum communication, and in particular, again, since we are very much focused right now on this stage on QKD, for the practical implications it has, we are running technologies, different algorithms and different techniques for performing QKD, and in particular, we have systems that are based on the discrete variables and on continuous variables. We have two different operators. We have running the Telefonica network on the one hand. We are running the on the Madrid academic network as well. They are interconnected. We are experimenting with the idea of two separated operators participating in the infrastructure. And we are from the very beginning having the different manufacturers, both for the quantum equipment and for the direct data transmission using classical connections. We are trying from the very beginning to integrate network operation to make the whole thing part of what we could call carrier grade, and we are trying to perform an integration that is as tight as possible. And you can imagine that there are very good usability and even economic sustainability reasons. Well, economic and energy, etc. So the idea is that we are applying patterns that are based on the SDN concept. So we are able to apply modern network management principles and seek for the integration at all the planes in the SDN architecture, at the application plane, at the control plane, and at the data plane with this sharing infrastructure. On the key basic technologies, some of them is part of the developments in which we are involved in the different projects I mentioned, like when it comes to the SDN-based stack. And we are trying to make the use of the infrastructure as transparent as possible for the applications running on top of the quantum communications infrastructure. And well, you have here a list of the different approaches based, as I said, on SDN principles that, in particular, we are developing, we are testing, and we are using the MadQCI as a way for further insights to contribute to its standardization and the wide availability of open solutions for this. Another key basic technologies are very much related with full operationalization, both at the level of how you manage, in the case of QKD, the keys or whatever the product of the quantum communications, and the integration with mechanisms based on SDN that we are applying right now, or in the process of applying for the for network control in general. And that includes something that for us is extremely important, precisely in a testbed, that is what is related with monitoring and telemetry. We have deployed and we have integrated this, the MadQCI, the general environment of the MadQCI, with our with the development we are making precisely for collecting, aggregating, and making available data from a variety of sources that is precisely by nature heterogeneous. And the idea is that we have deployed elements for extracting, aggregating, transforming, making the appropriate combination of sources and consumers of the of data that is provided by the different elements in the infrastructure, so we can not only, and with this important is for on the one side to contribute to make the whole thing work in a seamless way, applying SDN principles, and even thinking about even considering things like AI-enabled management and orchestration, but as well collecting data that is relevant for further evaluating and assessing the applicability of the quantum communication techniques, and how the interoperability and the different approaches, how they actually behave with real evidence. This is a list of the, I mean, we're going to start the list of the main use cases. This is the basic one, which is in which you use a quantum channel to exchange keys among a couple of nodes, and you use the keys that are exchanged to encrypt the traffic, the traffic that is exchanged through a physical connection that is parallel to the quantum channel, and as I said before, when the principle of sharing, that is as much as possible is shared by the same physical media. The important thing is that this is the typical the interconnection of two data centers, but we are even thinking about going beyond and thinking about future application in passive networks that will bring us something that is, well, this QKTTH here, that is, I mean, quantum key to the home. We are experimenting as well using these key distribution mechanisms for experimenting with software network management, everything that has to do precisely to apply SDN in managing SDN and NFT principles, and how we use it for orchestrating and configuring the secure mechanisms that leverage the additional flexibility that you have with network virtualization. We are experimenting with something that is connected, but this is very specific and important for us because we have found an important application environment here, which is about the proof of transit. So the idea is that you can demonstrate that every single packet in a flow goes through a particular path, what is particularly important if you think about virtualized functions that can move physically from a physical location to another. For this, there are techniques, and then we have been working on this in the ITF, and these techniques require a quite aggressive key material renewal processes. And we believe that's precisely, I mean, and we're exploring the idea of using quantum key distribution for this. Another case is precisely leveraging the distribution of crypto material using the same network links for 5G connections. We are currently making some experiments addressing mechanisms for AGV control in industrial environments, and directly on enabling B2B based services in 5G environments. Finally, we are considering as well the experimentation in the scenarios of eHealth. The first one, I mean, because here I would like to make a special emphasis on that we are considering two aspects that are quite important for us. And one is when we're talking about, in general, remote surgery, in which we are very much, I mean, the environment is very much sensitive to latency and the request for a high quality connection with a very high consumption of bandwidth. So this combination of capacity and latency with long-term security, because we're talking about health data, is something that makes especially challenging first the environment on security. Second, the requirements that this imposes on the mechanisms for co-propagation and integration of the quantum approach with the other elements. The second aspect is something that is even more, I would say, is more interesting, because we are opening precisely, we're moving forward quantum key distribution, and we are starting to use quantum connections, not yet for the synchronization of the interconnection of quantum states, but we are trying to leverage the lessons we have learned so far in deploying the QKD infrastructure, precisely to start working with secure multi-party computations, which is something that, if you think about, is extremely important in the current and the future environment, in which more people will rely on cloud infrastructure and on collaborative approaches without precisely willing to disclose data for whatever the reason. I mean the trade secrets or the privacy preservation or whatever. These first experiments are precisely applying mechanisms that are known as quantum oblivious transfer, and we have found that the initial results quite promising. And this is something that we are doing in cooperation with a large healthcare company here in Spain, what connects us as much to the real environment. Well, just as a conclusion, I would like to go away with the idea that precisely what we're using is trying to make the quantum communication mechanisms, I mean, make them, if you like, carrier grades, suitable to be part of the future services that network providers will be able to offer to society in the future. So we are very much focused right now, for obvious reasons, on QKD and on the direct demands of our real customers, and we are trying to cover the whole range of services, first in support of our services and of the way in which we provide normal services, so to say, and at the same time we're trying to involve a particular set of users that are highly interested in this first steps with QKD in particular, and and quantum communication in general, trying to involve them and make part of the use cases and the evaluation of the technologies. From the very beginning, we have tried to make it as close as possible to the real environment, and it's multi-vendor from the beginning, it's multi-operator, and is multi-users. And we are trying to precisely apply standards, contribute to the evolution of standards, because they are now evolving, and try to get some operational experience based on real data. Well, basically, all in all, what we are trying to do is precisely to make an environment for making quantum communications happen in the closest as we can to a real world conditions, which is, we know, makes things difficult, but on the other hand, makes things, well, not only makes more fun, but allows us to gain what is a real operational experience. So, well, that's all on the MadQCI. I hope that I will be happy to continue discussing about this with you later on. So if you're interested, please contact me. Thank you so much for your attention.